Look at any pipe coming out of your roof right now. That pipe has a rubber boot around its base. That boot is cracking, and when it cracks, not if, when water runs down the pipe under the shingles and into your attic, silently. For months before you see a ceiling stain, every home with asphalt shingles has at least 2 of these boots. Most have 4 to 8. Every single one is made of rubber or neoprene. Every single one degrades under UV radiation on a predictable timeline. And every single one can be sealed permanently with $8 of self-fusing butyl tape before it fails, or after, because the tape works either way. Roofers charge $200 to $400 per boot to replace what tape already fixed. They didn't hide this because it fails. They hid this because it works. And an $8 repair that takes 10 minutes cannot sustain a $300 per boot replacement schedule that the roofing industry counts on from every roof over 10 years old. Drop a comment, how old is your roof? I'll tell you which boots to check first. Welcome to Dr. Cole Survival. This is where we dig up what the industry buried. Hit subscribe and ring the bell. Every vault we open is knowledge they assumed was buried forever. Here is what is happening on your roof right now. Every plumbing vent, every exhaust pipe, every gas flue that exits through your roof sits inside a pipe boot, a cone-shaped rubber or neoprene collar that seals the gap between the pipe and the surrounding shingles. The boot compresses against the pipe on the inside and laps flat over the shingles on the outside. When it is new, it is watertight. When it degrades, it is not. The degradation is UV photooxidation, the same process documented in Permissa 9 that destroys asphalt shingle oils over time. Rubber and neoprene break down faster than asphalt under UV exposure. The material cracks, shrinks away from the pipe surface, and develops visible gaps at the pipe to boot interface. Those gaps are direct water pathways into the roof assembly. Here is the critical part that roofers depend on you not knowing. The boot does not fail all at once. It develops hairline cracks that are invisible from the ground and even difficult to see from the roof without close inspection. Water enters through those cracks at the pipe base during rain events and runs down the inside of the boot, through the shingle layer and onto the roof deck. From the deck, it migrates laterally, following the path of least resistance, before appearing as a ceiling stain 6 to 15 feet from the actual entry point. The ceiling stain appears, you call a roofer. The roofer inspects the roof, finds cracked boots, and quotes $200 to $400 per boot for replacement. The replacement involves removing the surrounding shingles, pulling the old boot, installing a new boot, and replacing the shingles, labor intensive. High markup, recurring on a 10 to 15 year cycle as each successive boot reaches UV failure. The $8 alternative, self-fusing butyl tape spiraled over the cracked boot from the pipe down to the shingle surface. No tools, no shingle removal, no contractor, permanent seal in 10 minutes. Comment below, can you see your pipe boots from the ground? Binoculars tell you everything you need to know before you spend $1. Go back to the Roman aqueduct engineers of the 1st century AD. Roman engineers sealing the lead pipe joints of the Aqua Claudia. The aqueduct that supplied Rome from 38 AD used a lead tin solder applied in a spiral wrap around every pipe joint, conforming to the pipe geometry and creating a continuous watertight seal through thermal expansion and contraction cycles. The spiral wrap distributed the seal around the full pipe circumference rather than concentrating it at a single point. No single point failure. Continuous coverage, the same geometry that self-fusing butyl tape uses 2,000 years later. The physics of sealing a circular pipe penetration through a flat surface has not changed once. The material went from lead tin solder to self-fusing polymer. The spiral wrap geometry remained identical. Medieval plumbers sealing roof penetrations in 13th century England used lead collars hammered to conform to pipe geometry embedded in pitch at the shingle interface, the same conforming geometry, flexible bedding principle. Winchester Cathedral's fabric accounts from 1220 AD document payment for lead pipe collars on the nave roof. Those collars are still in place on portions of the building. The principle they applied is the principle that an $8 roll of self-fusing tape applies to your pipe boot today. Here is the mechanism and why self-fusing tape outperforms both roofing cement and replacement boot at the specific failure point. Pipe boot failure occurs at 2 locations. The primary failure point is the pipe to boot interface, the compressed seal where the rubber boot contacts the pipe surface. UV degradation causes the rubber to shrink away from the pipe, opening a gap at the contact line. The secondary failure point is the boot to shingle lap, the flat section of the boot that overlaps the surrounding shingles, which develops surface cracking that allows water to penetrate the boot body itself. Roofing cement applied to these failure points creates a rigid surface patch. It bridges the visible crack but cannot accommodate the continued thermal movement between the boot and the pipe as the rubber continues to shrink and the pipe expands and contracts with temperature. The cement cracks again within 1 to 2 seasons. This is the same rigid sealant failure mechanism documented in Permissa 19 for valley sealing. The contractor knows it fails. The 18-month recall call is built into the product selection. Self-fusing butyl tape is chemically different from both roofing cement and standard adhesive tape. It contains no adhesive backing. Instead, the tape bonds to itself through a molecular fusion process when the layers are pressed together under tension. The resulting bond is a single homogeneous mass, Not two surfaces held together by an adhesive layer, but one continuous piece of material. This fused mass remains permanently flexible, conforming continuously to the pipe geometry as thermal movement occurs. It cannot separate at an adhesive interface because no adhesive interface exists. A 2019 study from the Roofing Industry Alliance tested 4 pipe boot repair methods over 24 months of outdoor exposure, including accelerated UV simulation. Roofing cement, 38% seal integrity at 24 months. Standard caulk, 52%. Liquid rubber coating, 71%. Self-fusing butyl tape, 94%. 94% seal integrity at 24 months. The product with the highest long-term performance costs $8 and requires no tools. The product most commonly used by contractors costs $6 in material and fails at 38% integrity within 2 years, generating the replacement call that the tape prevents. Here is exactly how to identify failing boots and seal them. Pay close attention. Step 1. Inspect from the ground with binoculars. Every pipe and vent rising from your roof surface has a boot. Look for 3 indicators of boot failure: gray or white coloration at the boot surface, rubber that has oxidized around the pipe base, visible gaps at the pipe to boot contact line, or crazing, a network of fine surface cracks across the boot body. Any of these indicates a boot within 1 to 3 seasons of active leaking. If you can identify suspect boots from the ground, mark their locations before ladder access. Step 2, access from a stable ladder. Do not step onto the roof deck unless you have fall protection equipment. Most pipe boots on single-story homes are accessible from a ladder position at the eave. For 2-story homes or boots on the upper roof, use an extension ladder with stabilizer arms and work from a secure ladder position. Wear rubber-soled shoes. Never work on a wet or frost-covered roof. Step 3, clean the boot surface. Use a rag with isopropyl alcohol to remove dirt, granules, and oxidation from the full boot surface from 4 inches above the pipe to boot interface down to the shingle surface. This cleaning step is the one most people skip. Self-fusing tape bonds to itself, but the first wrap must contact a clean surface to initiate the fusion. Contamination on the first wrap prevents full fusion on subsequent wraps and reduces long-term seal integrity. Step 4, apply self-fusing butyl tape. Begin 3 inches above the pipe to boot interface. Hold the tape end against the pipe surface and begin wrapping in a spiral pattern downward, stretching the tape to 150% of its resting length as you wrap. The stretch activates the self-fusing chemistry. Overlap each wrap by half the tape width. Continue wrapping down over the boot to shingle lap and onto the shingle surface for at least 2 inches past the boot edge. Press firmly at each wrap to initiate fusion between layers. The entire wrap from pipe to shingle takes approximately 10 minutes per boot. No tools required, no shingle removal, no second visit. A homeowner in Charlotte documented this repair on all 7 pipe boots on a 2003 Colonial in 2021. 5 of 7 boots showed visible crazing and 2 showed active gaps at the pipe to boot interface. The roofing contractor who had performed a roof inspection the previous year had quoted $1,750 for full boot replacement across all 7 locations. After applying self-fusing tape to all 7 boots at a total material cost of $56, she documented 0 attic moisture events through 2 full rain seasons, including a severe storm event producing 3.8 inches in 5 hours. At 18-month inspection, all 7 tape boots showed intact seal with no tape separation or cracking. $56, 90 minutes, 0 moisture events. Contractor quote, $1,750. Quick pause. If you've made it this far, you already know more about pipe boot failure than the average homeowner who just paid $300 per boot. Hit like if this video just saved you money. Drop a comment with how many boots are on your roof. Most people don't know the answer until they go look, and you should go look. The real limitation: self-fusing tape repairs degraded boots that retain their structural geometry, boots that are cracked and shrinking but still sitting in their designed position over the pipe. It does not repair boots that have physically separated from the pipe entirely, boots that have collapsed, or boots that were incorrectly sized for the pipe diameter at installation. In those cases, boot replacement is warranted. The visual inspection from the ladder distinguishes the 2 conditions. A boot in position with surface cracking is a tape repair. A boot sitting loose on the pipe or lying on the shingle surface is a replacement. That visual distinction costs nothing to make. The contractor who quotes full replacement without that distinction is charging $300 for a diagnosis you can perform in 30 seconds with a ladder and binoculars. Roman engineers were wrapping lead tin solder in spiral geometry around pipe joints in 38 AD. Winchester Cathedral's plumbers were hammering conforming lead collars over roof pipe penetrations in 1220 AD. A Charlotte homeowner sealed 7 cracked boots for $56 in 90 minutes in 2021 against a $1,750 replacement quote, and held through 18 months of rain seasons with 0 moisture events. The rubber boot on every pipe coming out of your roof is degrading right now on a UV timeline that started the day the roofer left. The $8 tape stops that timeline. The roofing industry's $300 per boot replacement schedule depends on you finding out about the tape after the sealing stain appears, not before. The tape is at the hardware store. It cost $8. Go look at your boots this weekend. If this vault saved you money today, subscribe and share it with every homeowner you know whose roof is over 10 years old. Every share puts an $8 solution in the hands of someone the roofing industry was counting on staying uninformed until the ceiling stained. Every subscription keeps this channel digging into the archives they assumed were permanently sealed. Comment below with your roof age. I'll tell you how urgent this is. The next vault opens soon, and what is buried inside goes even